I'm working on my 8th standard on work energy, and this problem is telling me that there's a construction worker that is pulling a tub of cement over to a place that he needs to use the cement, and he's pulling with a force of 60 newtons. The angle that he's pulling forms a 32-degree angle, and the tub weighs 15 kilograms. The distance that he will pull the tub of cement is 1.5 meters, and it's telling me that the ground is rough, so there's a frictional force of 16.7 newtons, but there is also hard wind pushing back on the tub, and the construction worker pulling the tub, it is pushing back at 13.4 newtons. And then it tells me that the construction worker started pulling the tub with a speed of 0.5 meters per second. And he's pulling it horizontally. And then they're asking me, how fast is the construction worker pulling the tub after it was being pulled 1.7 meters? So first what I did was I drew a free body diagram. And on my free body diagram, I have the force of the worker pulling on the tub. I have the frictional force pulling back on the tub and the wind pushing back on the tub. And it is at a 32-degree angle. And then I know kinetic energy equals 1/2 mv squared. I know the total work equals to the change in kinetic energy. And then my system is on the tub. The total work, the work done by the worker plus the work done by the friction plus the work done by the air equals the change in kinetic energy. To find the work done by the worker, I have F times delta R times cosine theta. Find the work done by friction. I got negative friction times delta R. The reason why negative is negative because it's going in the same. Well, it's going parallel as delta R, and then since it's like around 180 degrees, it'll be negative. And same thing for the force of air. Only it'll be negative force of air, delta R. And what I did is I've plugged in the numbers for each and then found the work done. And after that, what I did was I substitute 1/2 m. V, since it's the change in kinetic energy, is V2 squared minus V1 squared. After that, I wanted to solve, once I plugged that all in, I'm solving for V squared. So what I did is divide it by 1/2 m to the other side and add V1 squared to the other side, square root both sides. After I square root both sides, V2 equals square root of 2 F times delta R times cosine of theta minus F R delta F of F delta R minus F of A delta R divided by mass plus V1. I plugged in all my numbers and I came out with the velocity of 2.3 meters per second was how fast the construction worker was pulling the tub after it was being pulled at 1.7 meters. And that is how you solve this problem.